Welcome everybody. So in today's lecture, what question we will be doing is in front of your screen naturally. So it is basically the kth largest element in an array. So what does this mean? So for example, if you're given an array and you have to find the second largest element in that array, so that is being mentioned by the word kth over here. So over here, what we have been given an integer array called nums and an integer k. So return the kth largest element in that array. So I have to note that kth largest element is in the sorted order, not the kth distinct element. So what this line means over here is, so for example, if I say kth element, for example, k is 2 here, so it does not refer to this element over here or this element over here. It refers to the element in the sorted manner and which has to be the largest element. So we have to sort this element, and naturally when we sort this element, we will get some 1 2 3 4 5 6, and 6 is the largest element and the second largest element is k, hence output is 5. So there are two techniques. So we've got this question over here, which is basically saying the kth largest element. Say kth largest element, we have to find largest element. So naturally what we can think is, brute force solution is, I will sort it, and once I sort this, I will just take the kth element or k minus 1 index element if I am sorting it in the descending order, and if I'm sorting it in the ascending order, so I'll just take n minus k minus 1, and if suppose it's in ascending order, right? So this will work because at the end of the day you have to find the kth largest element, right? So this will definitely work, but as the name suggests, this is brute force, it's not optimized, and sorting will basically take the code over here to O of n log n. So the time complexity is O of n log n. So can this be more optimized? Should be the thinking, should be the mindset. So it can be more optimized. How can it be more optimized is what we will be discussing right now. So we'll have to make sure, and we'll have to use a data structure called heap, and in heap also most specifically min heap. So if I've got this element over here like 1 3 2 6 4 5, which was the first case over here, what I can do is I can insert this inside in a heap, and suppose if k is given as 2, so we've been given two things over here, right? We've been given that array, so the array is over here, and we've been given k. So so what I can do is I can insert these elements into this heap, and what this heap would do is, if it's a min heap, it would sort the shortest element to the top. And what I can do is I can make a barrier k, and I can say that anything that is increasing, whenever the length of the heap is more than k, I will pop it. That. So at the end of the day, I will only get kth elements. And over here, the top of the element would be the second largest, so the kth largest element, because the bottom would be the largest element, right? Because since it's a min heap, so the bottom would be the largest element, or not necessarily the largest element, but the k might be the largest element. It's not sure. It can be anything. It can be the k minus 1th largest element, but the kth largest would be the shortest among those elements over here, and it will be at the top. And since it will be at the top, we can just output that. So let's do a dry run. So this is what basically the optimized solution would be, and this optimized solution would solve the problem in O of n. Otherwise it was supposed to be solved in O of n log n if you would have just sorted the element and would have just got to the kth index, respective index. But when we use min heap, we are able to solve this in O of n. So that's just linear traversal. We are able to solve this in linear complexity. So if we dry run this, So I'll just take a shorter example. So for example, we've got 1, 3, and we've got 2 here, and we've got 4 here. So the question is, find the second largest element here. So if I'm supposed to find the second largest element here, of course we know naturally it is 3. So what I will do is, this is the heap, and I will make the barrier over here. So this barrier can only take 2 elements. Okay, it can only take 2 elements, and when I insert 1 is over here, all good, it's not crossed the barrier. And when I insert 3, it's still all good because it's not crossed the element. And when I insert 2, that is where it will cross the barrier over here. And what would happen is, when I increase 2 over here, it will be in the heap. So it will be sorted in a manner where the shortest element will be at the top. So we'll have 1, we'll have 2, and we'll have 3 here. We'll have these 3 things, because whenever I insert it, and since it's a min heap, the shortest element would be at the top. It can also be 1, it can also be 1, 3, 2, we don't know. It can also be that, it can also be 1, 3, and 2, but the shortest element will be at the top. And so now whenever it increases the barrier, I will just pop the first element, or when I'll just pop this up, and when I pop this, I'm only left with 3 and 2, and I'm left with 2 and 3. One second. I'm left with 2 and 3, and now I have to insert 4. When I insert 4, it again over supersedes the boundary, and when this happens, when I'm inserting this, the shortest element will be again at the top. So now I'll be left with 2 and 3 and 4, and I will pop this up, and so I will only be left with 3 and 4 at the end. And then we have traversed the entire array. And after traversing the entire array, I can just output this. So now let's code this. So now heap is implemented with the help of the data structure priority queue. I have made a video on that. The link would be in the description. So this is the priority queue, and the priority queue is basically having 3 parameters. The first one is the type of element that will be inserted, and then the container which will have the element, and then the comparator. So by default, priority queue will be giving a max heap, but we want it to be giving a min heap. So we'll be using a function comparator which is greater int, and we will name this as pq. And what we have to do is, we'll just use an auto operator, and we'll just give insert nums over here. So that's it, and then all we've got to do is pq dot push. We have to do pq dot push basically. pq dot push num, and if pq dot size, if the pq dot size is greater than k, that means what we just saw, right? If it moves more than that barrier, we'll have to pop before top element. So we'll have to pop the top element. So it's pq dot pop, sorry. pq dot pop, and that's it. And then when the traversal is done, we can just return the top element, which will be our answer, and that's it. And when let's see, hopefully no errors are over here. Okay, compile time error, sorry, you have to do pk more greater than k. Accepted. So let's submit this. And it's accepted. So now we are able to solve this in O of n, and we are done with the question. Thank you for watching.